CompTIA A+, 220, 1101, and 1102. Modems, routers, hubs, and switches. Cable modem. A cable internet connection is usually available as a part of cable access TV, CATV service. A CATV network is often described as a hybrid fiber coax HFC, as it combines a fiber optic core network with a copper coaxial cable links to customer premise equipment. It can also be described as broadband cable or just as cable. Cable based on the data over cable service interface specifications, DOCSIS, supports downlink speeds of up to 38 megabytes per second, North America, or 50 megabytes per second, Europe, and upload links of up to 27 megabytes per second. DOCSIS version 3 allows the use of multiplex channels to achieve higher bandwidth. Installation of a cable modem follows the same general principles as for a DSL modem. The cable modem is interfaced to the local router via an RJ45 port and with the access provider's network by a short segment of coax terminated using threaded F-type connectors. More coax then link all the premises in a street with a cable modem termination system, CMTS, which forwards data traffic via the fiber backbone to the ISP's point of presence, and from there to the internet. Routers. The devices discussed so far enable physical links where the only type of addressing used identifies a host hardware interface. Ethernet switches and Wi-Fi access points forward frames using MAC addresses. A network segment is where hosts can send frames to one another using their MAC addresses. Digital modems, ONTs, and cellular radio transmit data over DSL cable, fiber, satellite, and cellular links to connect a local network or device to an ISP. This is typically a point-to-point link and so does not require unique interfacing addressing. These network segments use different media types and have no physical or logical means of communicating with one another. When you want to connect a local network to the internet, you need to use a protocol that can distinguish between the private LAN and public WAN, and an intermediate system with interfaces in both networks. The protocol used to implement this is the Internet Protocol, and the immediate system is a router. Hubs. A hub is a legacy network hardware device that was used to implement the 10-base-T and the 100-base-T Ethernet cabling designs. This design is referring to a star topology because each end system is cabled to the connector. The hub. A hub has a number of ports typically between 4 and 48, and each computer is cabled to one port. The circuitry in the hub repeats an incoming transmission from a computer attached to one port across all the other ports. In effect, the computers seem to be attached to the same cable. Each computer attached to a hub receives all the traffic sent by other connected devices. This is referred to as a collision domain. Hubs. Each computer will ignore any frames that do not match its MAC address. However, when lots of computers are in the same collision domain, performance is reduced as only one computer can send a frame at only one time. If two computers try to send at the same time, there is a collision and they must wait for a random period before trying again. The computers are there, the more collisions there are. The computers contend for a share of the media bandwidth, and all communications are half duplex. Half duplex means that the computer can send or receive, but not at the same time, as well as the effect of contention on performance. There are no hubs that are compatible with gigabit Ethernet. These limitations mean that almost all networks are now based on Ethernet switching. You are only likely to encounter a hub being used in a very specific circumstance, such as where legacy equipment must be kept in service. Switches. A solution to the issue of collisions was first provided by inserting Ethernet bridges between hubs to break up collision domains. Ethernet bridges were quickly refined to the Ethernet switch appliances that underpin almost all modern office networks. Like a hub, an Ethernet switch provision one port for each device that needs to connect to the network. Unlike a hub, an Ethernet switch can decode each frame and identify the source and destination MAC address. It can track which MAC source addresses are associated with each port. When it receives an incoming frame, the switch intelligently forwards it to the port that is a match for its destination MAC address. Switches. This means that each switch port is a separate collision domain, and the negative effects of contention are eliminated. Each computer has a full duplex connection to the network and can send and receive simultaneously at the full speed supported by the network cabling and NIC. When a computer sends a frame, the switch reads the source address and adds it to its MAC address table. If a destination MAC address is not yet known, the switch floors the frame out of all ports.